All right, welcome to the second step in this. So now that you watched the first video and you hopefully understand what we're trying to accomplish, second video is going to walk you through actually the formal steps that you need. Now, I shared online a sheet that looks pretty much like this. Now, this is filled in, so we'll get to that in a second, but it says, let's run a test from the previous page, and it shows you all the steps. So what I'm going to do is I'm going to walk you through all those steps based off of this problem. So you should have that sheet with you. We can fill it out step by step and hopefully answer any questions about what needs to be included in order to get this credit. Not just for the submission problems, but this is the same thing you'll do when you create your own problem for your project. So first thing I want to do, and I'm going to kind of break this up into pieces. I'm going to use a little shade function. One of the things that's very good to do is just lay out your key terms. Now, this is not necessary. This is not part of the grading process, but I think this is important to put down so you can have this later, because no matter what tool that you're going to use to work what we call the mechanics of this problem, you'll need to have this out. So the P is the known population probability, which is the 82%. We had 498 people have jobs within a year of graduation out of the 562. Those are symbols are X and N. Then the P hat is simply just the 498 divided by 562. If you go to your calculator, you get around 0.8861, I think. So I'm just going to go 0.886. So the P, this is your sample probability. This is the probability. Is this significantly different than this? So the first thing is it says here, let's state out the hypothesis. So this is both formal and informal. The formal is writing it mathematically this way. The other is informal writing this way. It's a good thing to know both. Depending on your major, your degree, you can use either one. But it is important to know both symbol and just kind of writing it out what we're doing. So I wrote out my HO is that P is equal to 82. Nazareth has an 82% job placement. We're trying to show that Nazareth is better than the national average of 82%. And here, what level of p-value willing to accept is one or two-tailed. We only care about the one side, so we're going to state it's a one-tailed test at 5% significance. So that's the first part of this. We have to state what exactly are we doing in the process. The second part is going to be a paragraph. And again, this can be just a statement, or you can put this into a paragraph. I would suggest on a problem, we'll just put it into a paragraph. If you want a bullet point, just like I did here, I am perfectly fine with that as well. I'm sure you know how to go from a bullet point to a paragraph on your own, so I'm not too concerned. So for the modeling piece, what we need to do is we need to satisfy these four conditions. The conditions are they need to be independent of each other, they need to be random. You can't sample more than 10% of the population. The reason why you don't do that is if you can sample more than 10%, you just do everybody, just sample everybody as opposed to just the 10%. And then there's a success failure condition, which means that you have to keep going until you have at least 5 yeses and 5 nos in your condition. So in this case, we need to have at least 5 people that said yes, they graduated and had a job, and at least 5 people that said no, they didn't. So this sets up what's the minimum we can do, and this kind of limits us on the other end, which is how many can we ask? We don't go above 10%. We have to make sure we have at least 5 that say yes and 5 that say no. And then you just put it in a paragraph just like I have here. We're assuming the job placement is independent and so on. So if you just kind of pause the video and you want to read that, this would be a paragraph that would need to go into this for the modeling section. So now that we set that up, we have the mechanics. And I put a blank here for one primary reason. Now on your sheet, there is some information filled in here. I'm not going to ask you to do that because the truth is it's a long kind of process that you can do with technology. And I'm going to show you 2 different ways to do it, but they're both the same. One way is, one of these favorite graphing calculators that we all had from high school, right? At some point, I'm sure you guys all had some sort of situation where you use one of these calculators. So you can either use this calculator or you can go to a website just like this one. So what I did is I literally went to Google and typed in, it's called a one proportion hypothesis calculator. The first one wasn't as good, but this Math Tracker one was pretty good. So if you click on it, and you'll notice it wants to know your null and alternate. It wants to know your P0, which is your P, your N, your X, and your significance level. And then if you click continue, or if you click solve, it'll solve it for you and get your p-value. I'm not going to do it on here. I'm going to do it on the calculator, but you will get the same exact results. So I don't want you to kind of panic. Depending on where you get it, the important results are just to kind of list out the information that you had. So if you have a graphing calculator, you just hit stat, go over to where it says tests, and then scroll down to number 5, which is a 1 proportion z-test, because we're dealing with proportions and we're doing 1 proportion test. Now the P0 is your P, and this is where, if we go back to before, this is where I think this is important. This P or P0, P initial, that's your 82%. But you'll notice all that information, the P, the X, the N, is going to be put in here. Now, we don't need the P hat. I like putting it there. Some, computer programs might ask you to do the P hat, some might not. So let's just put this in as a 0.82. We're going to go down 498 for the X. And then this section here where it says proportion, we are trying to show that it's greater than. So if you want to show it's not equal to, if you want to show it's less than or greater than, you would select that. We want to show that our sample is greater. So we're, again, going back to this, really looking here, we're trying to show greater than. So it's important you put here, and then go down to calculate, hit enter. And this is the value, this is what needs to be put on there. So what you would need to do is copy and paste this onto your work that you're turning in. So the power of technology, I plopped up here. I did a copy and paste. You can do a copy and paste if you're going to type everything out. Otherwise, you can just handwrite this stuff out. Now, the key part that we're looking for in here, and the key that we're trying to understand, it's important, is this right here. So this is the probability of this event happening. Okay, so again, a calculator P hat of the 88.6% gave us all this information we're trying to see. And what we determined here, because if we look at this, we're going to test at 5% significance. What this 5% significance means is, and very important you understand this, is that ties into this right here, which we call our p-value. If that p-value is less than 5%, we go back, remember the previous page on that bell curve, what that means is it's different than, it's significantly different than this 82%. So because this is less than 5%, and it happens less than 5% of the time, in this case, the E negative 5 means 0.000225. This is the probability of it happening, and we're comparing that to the 5%, which this is much less than 5%. So since this is less than 5%, we can conclude that our sample that we took from Nazareth is significantly different than 82%. So we can go with our alternate hypothesis and say that we reject the null and go with the alternate hypothesis. So what does that look like? Let me type it out for you and I'll show you what it looks like. So this is what it would look like as far as our conclusion. So when we state our conclusion, since our p-value is less than 5%, so again this, and we determined 5% was our significance level, we reject the null hypothesis and accept the alternate hypothesis. Nazareth College has a higher job placement rate than the rest of the country. So this is what needs to go into it, and this is what it will be. I will post another video with some more solutions and wish you the best.